Okay, so today we're going to talk about currents, types of currents, and transformers. So there's two types of currents that you need to know about. Okay, so one is a direct current. And so this is where your charges, which are technically electrons, that's why we call it electricity, move in one direction. Okay? An example of a direct current would be really any battery. Okay, and that's because they have fixed terminals. Okay, an anode and a cathode, a positive and a negative, like they have fixed terminals. Okay? Now, there are some disadvantages to this. Okay? So one is, this is difficult to transform between high and low voltages. Okay, so you kind of lose some energy when you're trying to transfer between, and it's difficult to transport like through a wire, okay, over a long distance. Okay, so these are typically like short range type of things. Like we use the charges right away, like your battery in your car, or the battery in your calculator, or the battery in your phone. All of it is right there powering the thing that needs power. You don't have to send it somewhere. Okay, so we're going to contrast this with alternating currents. Okay, and this is where the charges are constantly change direction. Okay, so think of it as if they were vibrating back and forth. Okay, so an example of this might be in your electrical outlets on the wall. Okay, those use alternating current. Okay, so these have some good advantages. These are very easily transformed between high and low voltages, okay? And because they're easily transformed between high and low voltages, they're also easily transported over long distances. Oops, there we go. They're easily transported over long distances without really losing energy to friction or heat, okay? You can, so a good example of this would be like in your power lines, like that are sending energy to your electrical outlets, okay? So that's currents, different types of currents, direct and alternating. All right, so let's talk about transformers. Ow, I just paper cut myself, that hurt. All right, here we go, transformers. Okay, so you might want to pause to write down some of these pictures, but okay, so this is transformers. Transformers change one voltage to another. Okay, so these are usually alternating current. Okay, so you have two different ones. You have a step up and a step down. Okay, so a step up transformer raises voltage by increasing number of turns. And so if it increases the voltage, then it decreases current. So this is a step-up transformer. So you would have your primary coil. So this is where the power is going in. Okay, primary goes in, secondary is where it goes out. So primary coils, okay, around this transformer. There's less turns of coil, or coils themselves sometimes. I call them turns, but there's less turns of coil on the primary than on the secondary, okay? N is the number of turns of coil. So in a step up, okay, the number of turns on the primary coil, so P for primary, is always less than the number of turns on the secondary coil, okay? So less on the primary, more on the secondary. Okay, there is a formula, and it's on your formula sheet, but it's kind of in a weird way here. But if you look on your formula sheet, you have this one right here. And they use 1s and 2s, and I use secondary and primary. So it's there, it's just not quite the same. It's not quite perfect. But this is, you can say the 1s are primary and the 2s are secondary, or you can do secondary over primary. It doesn't really matter as long as you have both of the types on one side and both of the others on the bottom, okay? So the number of coils on the secondary divided by the number of coils on the primary is equal to the voltage on the secondary over the voltage on the primary, okay? Typically, power is conserved for both sides of the coil. So you have your primary power is equal to your secondary power. So power is current times voltage. So the primary current times the primary voltage is equal to the secondary current times the secondary voltage. Okay. Anyway, so an example of a step-up transformer might be a generating station. Or if you ever have to go to another country, sometimes they use like a different type of outlet. And so you have to buy a transformer for your American appliance, like a hairdryer or a Qi. And so you would have to use a transformer for that. So like a European to American converter. They usually even have like different shaped plugs than we do as well. So you can look that up yourself or travel somewhere, maybe after the pandemic is over. All right, so then we have step down transformers. And so again, you might want to pause the video and draw this, okay? But a step down, so this lowers the voltage, okay, by lowering, decreasing, right, the number of turns. So this is going to raise the current. So it raises the current. And so the number of turns on the primary coil is always greater than the number of turns on the secondary coil. So this one has a bunch, this one has less, okay? Same formulas apply up here that apply down here. These are the same. You use the same formulas for those, okay? It's just, that's a picture. So examples of where you might find a step-down transformer might be at a power station. So that would be your house. Your house would be a power station, okay? Because the voltage coming through the power line is probably really, really high. But the current is low. And so in your house, you would want it to go into your house at a lower voltage, but increase the current, okay? So converting at your house from the power line into your house, that would be a step down. Another one might be an American to European converter for an appliance when you go overseas, because that one you would want to lower the voltage going into your appliance, right? If you were going from American to European, you'd want to lower the voltage by increasing the current, okay? So those would be examples. Okay. All right, so let's do a little math with transformers using these equations. Okay, we're going to do a little math. Okay, so I made up a silly thing. Now this is very similar to your homework that you have tonight, okay? So you have electricity is coming out of a transformer with 200 volts at 30 amps. So if it's coming out, that would be secondary, right? So it's coming out 200 volts and 30 amps. So your secondary voltage is 200 volts, and your secondary current is 30 amps. It went into the transformer's primary coil of 300 turns, okay? So my primary coil has 300 turns with 5 amps. So my primary current is 5 amps. And I want you to fill in the chart and show all work below. Okay, so I've filled in part of it, so now I just have to figure out the rest. So I can probably start by figuring out the power on my secondary coil. So my power on the secondary coil is going to be I times V. Well, I is 30, V is 200. Okay, and so we stick that in our calculator. All right, so 30 times 200, and you get 6,000. So 6,000 watts, okay, which is also known as 6 kilowatts if we were, kind of keeping score there, okay? So my secondary is 6,000 watts. So that means my power is conserved, okay? So my primary power is 6,000 watts as well, okay? So now I can find my primary voltage, right? So my primary voltage, okay, so if P equals IV, then V equals P over I. So my P is 6,000 and my I is 5. I get 1,200. So 1,200 volts. Okay, so now I just have to find the number of coils, number of turns on my secondary coil, okay? So I'm going to use that formula that I just showed you, right? So my V secondary over my V primary is equal to my N secondary over my N primary. So I'm just going to plug that in just like it is, right? So my V secondary is 200. My V primary is 1,200. Number of turns of secondary is what I don't know. My number of turns primary is 300. So my secondary, okay, here we go. So my secondary, I'm just going to cross multiply, right? So my 200 times 300 is equal to my NS times 1,200. So I'm just going to do 200 times 300 divided by 1,200. And that gives me 50 turns. So 50 turns. Okay. And that's how you do a transformer problem. Okay? All right, so you have some homework on transformers in your homework packet. And hopefully, yeah, so you have some transformers things, and so you have, I think, you have 7 transformer problems in your homework, and then you have another 5 complex circuits to work on for homework. So make sure you complete all of it before next class. Okay? Good luck.